Let us switch over to problem number 36 now. This is a match the following type of a question. In fact, the four values what have been given in this particular matching, if one can remember them directly without any delay in the final examination, without any further calculation in the final examination, you can directly write those values. That is the advantage what you are having from this particular problem as such. That is problem 36 I am talking about. Let me read it out first. A charged particle drops through V volt. That of course we can understand the potential difference that has been applied across the charged particles is given as V volt. Match the de Broglie wavelengths for the given particles. That is the question. He is just giving us four particles in the first column and corresponding de Broglie wavelengths in the second column as such. So what are those four particles and what are the corresponding values he has given? Let me first of all write. Then you can all understand directly what are the correct values to be remembered for each particle given in the first column. So let me just write those particles first. He is just giving us particle that is in the first column. And of course he has mentioned here de Broglie wavelength. That of course is lambda. He has given in the second column. De Broglie wavelength and particle. What are the four particles he has mentioned? Let me first of all give you. The very first particle he has given us as electron. And the second particle he gave us as deuteron, which is of course the isotope of hydrogen is deuterium. Deuterium ion he has given as the second particle here. And third one is an alpha particle he has said, and fourth one he has given you as a proton. So first an alpha particle and the fourth one he has given a proton. These are the four particles mentioned. Next, if you take the corresponding de Broglie wavelengths, he has mentioned once again four different values. He has not given the total value because V will be a variable there. So he has given you a simple step like 0.0817 by V under root. This is the first value provided to us. 0.0817 divided by V whole under root. The second value as mentioned is 0.0102. So you can write 0.0102 by V whole under root. He has given you as F. The next one he has given you is G. He gave a value 150 by V. 150 divided by V whole under root. And the last one is given as H. 0.0409 divided by V. 0.0409 divided by V. This under root. These are the four values given. No doubt you all can calculate them. That's not a big task. But waste of your time you will not have in the final examination if you know these values directly. So what exactly you have to remember in general is de Broglie wavelength lambda is equal to H by mv, which of course we can rewrite the same this way as H by under root 2m into QV. So what is the other version of this one? You look at h by root 2mq whole divided by v. That is actually the value. And of course, if you take these values right into the root, then what will you get? You check once again in this particular case, please. If you take this one directly into the root, you can directly write this, of course, comes under root v. So what can we write now this one as? H square by 2mq into v whole under root. In fact, this is the equation what has been taken by him. In fact, we also used to take the same equation, but h is 6.6 into 10 power minus 34. We know that value very much. That much square, okay, you have to square it up, fine. Twice mass of each particle is to be considered. First one of electron, 9.1 into 10 power minus 31 kg. Second one of deuteron, the mass of course is going to have 2 units. That of course you can say twice that value of a proton, 1.67 into 10 to the power minus 27 kg. Next one, alpha particle. Once again its mass this time is 4 units. So 4 times that of a proton you have to consider. Likewise, the proton is 1 unit, 1.67 into 10 to the power minus 27 kg. Straight away we can write, there is nothing in that. Similarly, charge also. We can understand charge on electron, charge on deuteron, charge on proton, all the 3 are one and the same. 1.6 into 10 power minus 19 coulomb, fine. But one thing more you should understand here, of alpha particle, twice the charge of proton. So 2 into 1.6, it's 3.2 into 10 power minus 19 coulomb we write. But writing all the values and calculating them till the end, it's not advisable for us to do the same methodology taking in the final examination. Not that mean we cannot calculate. It's not a big task for any of us. In fact, we can calculate easily, but it takes time. That is definitely going to be a waste of time for us in the final exam. So best suitable thing is, remember these values corresponding to these 4 particles. Because most commonly asked particles are these only, these particles only. Suppose if they give something additional over there, there is no other option left for us excepting calculating everything using this particular formula. There is nothing in that. But for time being, you better remember these values now. So what is the correct pair? You just have to take in each of the cases like. For electron, it is going to be G. This you remember thoroughly and once for all. You can certainly understand, for electron, de Broglie wavelength can be calculated roughly as 150 by V under root. What is that V there? It is the potential difference that has been applied across the electron which is in motion there. So that is the point what you have to understand. And of course for the deuteron part, deuteron, it is just going to be H. Now what is that value? You look at once again, under root 0.0409 by V. If you simplify for deuteron this value or this formula, according to that, you will be getting the same value. There is no doubt absolutely in that. So remember, for a deuteron, the de Broglie wavelength is nearly 0.0409 whole divided by V, right? Everything under root. Straight away we can take up like that. That is the second one. And of course for this C, for alpha particle, it is going to be F now. So for alpha particle, what will be the value? 0.0102 whole over V, whole under root. So better remember this value directly. That's what is my advice to all of you. And come down to the last, what is left? For a proton, it is going to be 0.0817 whole divided by V. So square root of 0.0817 whole divided by V. I once again repeat, for an electron it's simply under root 150 by V. For a deuteron it is root over 0.0409 divided by V. And of course for alpha particle it is under root 0.0102 around divided by V. And for the last one for proton it is under root 0.0817 by V. In fact, to make you people aware of these four values directly, we have taken up this problem. Otherwise, calculating all the four values and identifying all the four answers is not a difficult task. But if you remember them directly, you can save your time in the final exam, if at all such model question is asked there. Now let us see the options over there. First option, of course, for A to G, B to E, C to H and D to F. For the second option he has given A to G, B to H, C to F and D to E. And coming to the third option, A to H and B to E, C to F and D to G. And fourth option he said A to H, B to F and C to E and D to H. So what is the correct version over there? Correct match, that is going to be the second option. So directly you can understand the answer for this particular question as such is going to be B. So better remember these four values for de Broglie wavelength, at least for four particles. One is electron, one is a proton, one is a deuteron and one is an alpha particle. Sometimes they may ask you to write them in the ascending order, or to ask, rather they ask you to write them in descending order. Whatever be the case, roughly you can estimate what is the ascending order of that, what is the descending order of that. Any other version also if he gives, you directly will be in a position to answer that one. So this is problem number 36 what we have, right? The correct option is B for it, correct match is B for that. Switch over to the next number, that is 37. This problem is taken based on Moseley's law. What actually is a very important statement, all of you know. Based on that only, we have rearranged the elements in the periodic table. That also you might have discussed even in chemistry. But only point here we have to take up is its application we have considered in the form of a small problem. Let me read it out first. In X-ray emission, the wavelength of K alpha line for an element of atomic number 43 is lambda. Then the wavelength of K alpha line for an element of atomic number 29 is how much? For atomic number 43, K alpha line has a wavelength lambda according to the given problem. For an element of atomic number 29, what would be the corresponding wavelength of K alpha line? Of course, he gave four options again. The very first option is 9 lambda by 4. Second option is 43 lambda by 29. And third option is 4 lambda by 9. And fourth option is 42 lambda by 28. First and foremost, try to just recollect what is this concept of K alpha line in this particular version. You all in fact know X-rays which we are going to take up. In the case of an X-ray tube, there are two different types. Every one of you know those two types as well. One, of course, continuous X-rays we call them. One, characteristic X-rays we used to call them. And we know very well, continuous X-rays, they do not depend on the material which is used as the target in that X-ray tube. Whereas characteristic X-rays, they do depend on the material and its general properties of the target what is used in that X-ray tube. Now this version of K alpha line, K series, L series, like that different series whatever we are going to get there, They are all directly depending on the nature of that material which is used as a target in an X-ray tube. So once again, if you recollect, K shell if I take, L shell if I take, M shell if I take, like that of course 3, 4. When L electron is transiting into K shell, whatever the X-ray that is released in that particular process, we call that one as K alpha line. All of you are familiar with this. In the same manner, when an electron is transiting in between this M shell and K shell, that we used to get K beta line, the next one K gamma, K delta, K epsilon, and so on and so forth. That is what actually we call this one as K series. Exactly in the same manner, if an electron is transiting between M and L, that is called L alpha, N and L is called L beta, and so on. That is what we call it as L series. So this particular series, whatever we people are getting here, whenever electrons are transiting into that L shell over there, that is called L series over there. Now okay, according to this concept, for K alpha line, K beta line, whatever that is for K series, we people used to write Moseley's law like this. What is this concept of Moseley's law? First of all, the frequency of the spectral line, square root of the frequency of the spectral line obtained, is directly proportional to the atomic number of the target material which has been used over there in that X-ray tube. So you can directly write this way: root nu is equal to A into Z minus B. In fact, that is the equation what we people used to write as Moseley's law. And A and B, these two are called Moseley's constants, and the value of Z is atomic number. Nu represents the frequency of the spectral line thereby obtained. But of course, you can rewrite the same this way as root over, I am talking about nu is already there, it is converted into lambda now. Nu is equal to C by lambda under root, that is equal to A into Z minus B, we people used to write. So can't you just understand in this particular case that 1 by lambda is directly proportional to Z minus B whole square, please? In fact, this is the formula based on which this type of a question can be attempted. Now if you write the same in the form of a ratio, lambda 1 by lambda 2 is equal to Z2 minus B by Z1 minus B whole square. That is the usual equation. But all of you should understand, for K series, the value of constant B is taken as 1. For K series, B value is 1, we all know that. Therefore, you can rewrite the same this way: Z2 minus 1 by Z1 minus 1 whole square. So, the value of lambda 1 by lambda 2 is Z2 minus 1 by Z1 minus 1 whole square. That is the equation what we are having. But what are the values he has provided? Look at first. Z1 is given 43 and Z2 is given 29. So we can write this way: 29 minus 1, 43 minus 1 whole square. Directly this is 28 here and this is 42 here, whole square. Now in fact you can cut 14 there. So it goes twice, here thrice. So totally you be getting 4 by 9. But what is it we want in this case? Lambda 2 is equal to 9 lambda 1 by 4. That is ultimate equation. But one should understand lambda 1 is given in the problem as lambda. So directly we can take this way, lambda 2 is equal to 9 lambda by 4. That is the equation. In fact, lambda 2 in terms of lambda, we are getting 9 by 4 times the value of lambda. So if you look at that, what are the options he has given? 9 lambda by 4 the first option, 43 lambda by 29 the second option, 4 lambda by 9 the third option, 42 lambda by 28 the fourth option. So what is the correct option over here? The very first option itself is the correct one. So directly I can take the answer for this particular question is simply A. So what you need to understand in this case is, what is a K-series? First of all, you should recollect. K-series of X-rays, first and foremost, in the spectral line, in the spectra of X-ray, you will be finding K-series whenever electron is transiting into K shell from any other outer shell, like from L to K it is K alpha, M to K it is K beta, and so on and so forth. For K series, the value of B will be taken as 1, and accordingly we have got lambda 2 is equal to 9 lambda by 4 as the correct option, and that is tallied with the very first option given, that is A. Right? This is problem number 37 for us. Switch over to problem number 38 now. An electron in a hydrogen atom makes a transition from N is equal to N1 to N is equal to N2 state. The time period of the electron in the initial state is 8 times the time period in the final state. The possible values of N1 and N2 are, respectively, he is asking, what are the 4 options mentioned? First option, N1 is 8 and N2 is 1. Second option, N1 is 6 and N2 is 2. And third option, N1 is 4 and N2 is 2. And fourth option, N1 is given as 8 and N2 is given as 2. One can understand this particular question is based on Bohr's atomic model. The model which has been explained by Bohr as far as the structure or internal structure of an atom that's concerned, we have discussed different equations out of that. All of you can understand well according to the concepts given by Bohr. The radius of the orbit is directly proportional to n square. You all can understand this point thoroughly. So r is proportional to n square. That's known to us. Exactly in the same manner, velocity of an electron in an orbit having quantum number, principal quantum number, orbit number itself is principal quantum number, we all know that. That is inversely proportional to n. So r is proportional to n square, we know. V is proportional to 1 by n, we know. These two relations of course are known to us all. So that time, the time period if I write, in fact while taking up time period of any electron in an orbit, we take that one as 2 pi r by v. The distance travelled by the velocity. 2 pi r by v, we people used to write the same. I can write this way now. Time period is proportional to r by v. So you can understand this is proportional to n square and this is proportional to 1 by n. Ultimately what can we write now? T is proportional to n cube. This is the one what you have to understand. So not only time period is proportional to n cube, you have to remember. You even have to remember the frequency of revolutions of an electron in an orbit is proportional to 1 by n cube. So these concepts, if you directly can remember them, such model questions can be worked out very simply and easily. So what you have to remember here is, first one, radius of the orbit is directly proportional to n square, where n is principal quantum number or number of the orbit what has been mentioned over there. And the second concept over there is the velocity of an electron in an orbit having principal quantum number n there, that is inversely proportional to n. That is the second formula for us. In fact, second relation one has to remember. Now, if you want time period, generally time period of an electron in an orbit of radius r, we used to consider that one as 2 pi r by the value of v. That means time period is proportional to r by v, I can write. Accordingly, time period is proportional to n cube, I can directly take up. Now you look at the version what has been given in the problem. The time period of the electron in the initial state is 8 times the time period in the final state. So what he is talking about, you see now, time period in the initial state by time period in the final state. That is officially n1 cube by n2 cube. What is this ratio he has given? Time period in the initial state is 8 times the time period in the final state. So you can directly write this one is 8:1. So what you can understand straight away from this, n1:n2 will now be 2:1. So you can directly understand n1 cube by n2 cube when it is equal to 8/1. So n1:n2 automatically will be 2:1. So if you can identify this one, just like that you can identify from the options what is the correct one as well. Look at it first. The first option is given, n1 is 8 and n2 is given 1. 8 and 1, are they in this ratio? No, not at all. So first option is not correct option. Second option, if you look at, n1 is 6 and n2 is 2. What is the ratio according to that? It should be 3:1. But here we are getting 2:1. So it must not be correct. The second option is not going to be correct again. That is giving you n1:n2 3:1, whereas here it should be simply 2:1. Okay, forget. What next we have? The option C. n1 is equal to 4 and n2 is equal to 2. 4:2 if I take directly, I am getting 2:1. So that must be the right option. And fourth option also, if you want, you can check it once again. n1 is given as 8 and n2 is given as 2. So what will be the ratio there? 4:1 ratio. But here we are getting 2:1 ratio. So straight away you can understand this way, n1 must now be equal to 4 and n2 must now be equal to 2. Okay, this is one way of identifying the answer. Otherwise also you can do like this. If I just take n1 by n2 is equal to 2 by 1, or n1 is to n2 is equal to 2:1, n1 I can take it as 2 times k like, a constant. And n2 I can take it as 1 time k like, k is a constant like. If k is 1, if I consider, then what will be the value? 2 and 1. He has not mentioned 2 and 1 in the options. When k is given 2, then it will be 4 and 2. Yes, there is a possibility. When k is taken 3, for example, you will be getting here 6 and here 3. 6 and 3 option is not there. If I take k as 4, 8 and 4 option is not there. So no other option is going to be tallied other than this pair. So directly you can come to a conclusion. The correct answer for this particular problem 38 is C. So you can directly write answer as C for this one. So whether you directly work out this ratio and estimate the answer, or taking the value of k right from 1, 2, 3, estimate what is the corresponding pair that is tallied according to these values. What is the k here we people are taking up? K is taken as a constant here, nothing else. That is the point. So this is problem number 38 based on Bohr's model of hydrogen atom. That is the concept. Next number is 39th problem. In Lyman series, the shortest and longest wavelengths emitted are. In fact, everybody can directly mug those numbers. You can directly remember them once for all. But there is a small method for that. I just want to explain theoretically here. Lyman, Balmer, Bastian, Brackett and Fund series. 5 different spectral series we people are going to obtain whenever we consider hydrogen atom. If you take this one, Lyman series is possible when transition of electron from any shell into the first shell. Generally, we people used to take K, L, M, N, O like. When the transition is into K shell, Lyman series, into L shell, Balmer series, into M shell, Bastian series, into N, Brackett, and of course the next one is Fund. That order, okay, we know. But for all these, general equation you need to remember. What is the general equation here? 1 by lambda is equal to Rydberg constant R into 1 by n1 square minus 1 by n2 square. This is the basic equation by means of which we people used to calculate wavelengths of each and every spectral line that is obtained in the spectrum. So what exactly we have to look into? He is asking you shortest wavelength and longest wavelength. One should understand this way, shortest wavelength means the frequency is supposed to be higher. Longest wavelength means the frequency is supposed to be the least. Because wavelength and frequency, these two are inversely proportional to one another. So if you look at this equation, if n1 is equal to 1 and n2 is equal to infinity, from the last shell that is possible, if the transition is taking place right into the first shell, then wavelength will be minimum. When you just take up the same concept this way, if n1 is equal to 1 and n2 is equal to 2, then you will be getting the value of wavelength as maximum. So take the very first one first. 1 by lambda is equal to R times 1 by 1 square minus 1 by infinity square. It is nothing other than R. But probably you must be knowing it very well. R value is nearly 1 by 912. If you can remember this value, it is easy for you to simplify the remaining calculation. Otherwise, it takes time. So if that is the case, what will now be the wavelength minimum over here now? It's simply 912 angstroms straight. So what you should understand is this: the value of R is near around 1 by 912. And what about the second one now? This is for minimum I am talking. Then what is for maximum? Lambda max. R times 1 by 1 square minus 1 by 2 square. You can directly write this way, that R into, this is 1 minus 1 by 4, which now becomes 3 by 4. So 3 times by 4. That is 3R by 4. 3/4 of R. What is the value of lambda max now? That now can be taken as 4 by 3r. Look at that equation thoroughly. 4 by 3r, fine. But what is r around? Nearby value, 1 by 912. So if you write that one over here, 4 times 912 by 3. This 3 goes here, 304 times. So you be getting 1216 angstroms. So see the conversion there. Only point you need to remember is rough value of r. If you can remember this one, all those calculations, not only in Lyman series I am talking, in Balmer, Bastian, bracket, wherever and whenever you want, the calculation can definitely be made easier. So remember this value thoroughly and work out the values of minimum and maximum wavelengths thereafter in any spectral series, whatever that has been asked in the problem. But in this particular case, Lyman he is asking you, the first option he has given you is 912 angstroms and 1216 angstroms. And second option is 912 angstrom and 2432 angstrom. And coming to the third option, 608 angstroms and 1216 angstroms. And of course the fourth one, 608 angstrom and 2432 angstroms. 4 options are given that way, and ultimately the very first option is exactly the same values what we have calculated just now. So lambda minimum is 912 angstrom units and maximum value of lambda is 1216 angstrom units. Therefore, the correct answer for this particular problem is A. Likewise, you can work out for Balmer series, for Bastian series, bracket and Fund series also. These are all the concepts to be remembered for this type of a model problem. That is problem number 39. In the next problem, that is problem 40, my intention is just to remind you few results directly. This is a problem which has been given based on final results obtained while deriving the equations for different parameters in Bohr's model of an atom. Now I just read out first of all, in Bohr's model of hydrogen atom, there are 4 options given. Let me read out each and every option and try to identify which is the correct one out of them. In fact, it is a multiple answer type of a question. The very first option, radius of nth orbit is proportional to n square. Is it true or false? First and foremost, identify that. Already I have given you radius of nth orbit is directly proportional to n square. That 100% it is true. So the first option is correct. What about the second option you look at? The total energy of the electron in the nth orbit is inversely proportional to n. In fact, we all know that one very well. Energy, when we talk about, it is not inversely proportional to n over there. This is not a correct statement. You all can identify directly there. So second one is not correct, fine. What about the third? The angular momentum of the electron in an orbit is an integral multiple of nh by 2 pi. In fact, all of you know pretty well, see if I take the angular momentum is integral multiple of h by 2 pi. That integral multiple is taken as n. Then L is equal to nh by 2 pi we people used to call it. In fact, all of you know this was one of the postulates which have been made by Bohr. So what we can understand in that case, angular momentum is an integral multiple of h by 2 pi. That integral multiple here is n. So third one certainly is correct one. And come to the fourth. The magnitude of potential energy of the electron in any of the orbit is greater than its kinetic energy. All of you should recollect once again, an electron when it is revolving in a circular orbit, its potential energy is twice the kinetic energy what that electron has got in that orbit with a negative sign. So potential energy as a whole will be negative, and kinetic energy and potential energy ratio when you take directly, it's 1:2. So potential energy is twice the kinetic energy but with a negative value. Since potential energy is dominating there, total energy of the electron inside that orbit also will be negative by nature. So what is given in this fourth option, look at once again, the magnitude of the potential energy of the electron in any orbit is greater than its kinetic energy. It's obviously true, it's correct. So we can understand that D, the potential energy is greater than kinetic energy. In fact, what is the relation I said? Potential energy will be twice kinetic energy. But with a negative sign we people used to take up, because we know very well electron cannot be at rest over there. It is always in motion. So with reference to its rest position, when we are talking about energy, that we have to work on the system, therefore we take that with a negative sign. That is the concept. So what are the correct options out of the four? A is correct, C is correct, and D also is correct. So the correct options you can write here A, C and D. B is the only one which is not going to be true out of the total four options given. So this is problem number 40 what we have. Switch over to the next number, that is 41. If 13.6 electron volt energy is required to ionize a hydrogen atom, then the energy required to remove an electron from n is equal to 2 is how much? From the second orbit, n is equal to 2 means that is a concept there. And this question has been asked in 2002 IIT-JEE paper. Four options are given this way. The very first option is 10.2 electron volt. Second option is 0 electron volt. Of course, that will not be the correct option. You can definitely understand. It needs some energy at least to be removed from that orbit. It cannot be 0. So, okay, forget. And third option is given 3.4 electron volt. And fourth option is given 6.8 electron volt. All of you have seen already in the previous problem, just before this 40th problem, we have identified that energy is not inversely proportional to n. It is to be inversely proportional to n square. That's why that second option given in that problem was taken wrong there. Now exactly in the same manner, if you take energy here that is needed to remove an electron is equal to minus 13.6 divided by n square. That is the correct equation which one has to remember. So when you talk about 13.6 by n square, n is given 2. Therefore, minus 13.6 over 2 square now will be 4. So if you simply cancel this one, minus 3.4 electron volt, that is the energy, that is what is required. So one should understand one point here. Why this negative sign here? All of you in fact know this point very well. But why negative sign means it is the work what we people are doing on the system. Generally work is a scalar. Energy also is a scalar. We know that one very well. It cannot be given any direction. We don't even give also. Fine. But in spite of that, we write at times work or energy with a negative sign. What is the reason for this? Reason is very simple. When the system does the work, we people used to take that work as positive work. When we people are doing work on the system, that particular work is to be taken with a negative sign. So in fact, it is one such kind over here we people are getting. Therefore, it is minus 3 by 3.4. But options when you look at, he did not mention what is that value of that value of energy he is giving you, but he did not mention with a sign. So what can we understand? It is understood the magnitude only is just asking, not simply whether we are giving the energy to the system or the energy is being lost by the system or something. So energy required is how much? Energy required by the electron. Required by the electron. When we write this way, this can be taken as 3.4 electron volt. Suppose if they ask you how much energy you need to give to it, then okay, you can directly write with a negative sign, minus 3.4, because we are giving energy to the system, therefore it should be taken with a negative sign. That is the point. So this answer is exactly coinciding with the third option given in the problem. Therefore, the correct answer for this one is going to be simply C. That is the concept you have to understand as far as 41st problem that is concerned. Check the problem number 42 now. At another easy question, no doubt, but has been asked in IIT paper in 2000. How many electrons are there in M shell? That's what actually is the question. How many electrons are there in M shell? K shell, L shell, M shell. So N should be taken 3. N is 1, 2, 3. So what is the number of electrons formula? Number of electrons is equal to 2n square, that's all. So in this particular case, twice 3 square, which now becomes 18. So problem is not a difficult one. Just to remind you that this has been given in one of the examinations earlier. One of the very important most examinations what we are having, that is IIT paper 2000. So this was the question given and the correct option is 18 here, and he gave the options, first option as 8, second one as 18, third one as 32 and fourth one as 2. So which is the correct option now here? It now should be the second option as far as problem 42 that is concerned. That is the answer for this problem as such. Next number is 43. As per Bohr's model, the minimum energy required to remove an electron from the ground state of doubly ionized lithium atom. Of course, Z is given as 3 in the problem itself. Is how much? This question was given in 1997 in IIT paper. So 4 options given are like this: 1.51 electron volt, 13.6 electron volt the second option, 40.8 electron volt the third option, and 122.4 electron volt is the fourth option. That is what has been given there. So what we should understand first of all here, the energy that is required to remove an electron from the ground state, the basic one. So you can directly understand this way, the energy that is required is minus Z square into the value of E naught divided by N square. In fact, energy is inversely proportional to N square when you are taking Z as constant there. When you are comparing the same atom in 2 different cases like, but here lithium he is talking about, of which the value of Z is known to us as 3. And of course E naught value he only has given us, that of course we know 13.6 electron volt. It is a known value to every one of us. So if you look at that value, minus Z square into 13.6 by this value of 1 square, whether you write or not, hardly that matters, it is 1. Now what is it you people are getting directly? You look at, it's now minus 9 times 13.6. How much you are going to get? exactly 122.4 electron volt you will be getting. 122.4 electron volt with of course negative sign we will be getting, no doubt. But what is the question he is asking is just what amount of energy that is required. So required energy is 122.4 eV, we can directly write. So the energy required is going to be 122.4 electron volt. That is the correct value. Alright, so 122.4 electron volt, it is in coincidence with the fourth option given out of all the four. So automatically we can take it for granted that the answer here is D. So the fourth option is 122.4 electron volt. So that is the energy that is needed. If suppose Z is taken constant, energy is inversely proportional to n square. If Z is to be considered, better remember minus Z square E naught by the value of n square. That is the concept. Look at the next number, that is problem 44. A wonderful model question that has been given. In hydrogen spectrum, the wavelength of H alpha line is 656 nanometer. Hydrogen, that is alpha line, he gave 656 nanometer. Let us consider that one to be the wavelength lambda. Whereas in the spectrum of a distant galaxy, H alpha line wavelength is 706 nanometer. By taking H alpha line emitted by the galaxy which is at a certain distance, like a distant galaxy, what exactly the distance also is not known, it is long distance. It is a very far away place from us. If you consider that, what is the wavelength of H alpha line emitted by that galaxy there, in that, according to that, it is given 706 nanometer. This I take lambda dash. This is also of H alpha only. Lambda, that is wavelength of H alpha. That's what he is giving us. Now look at what is he asking for. Estimated speed of the galaxy with respect to the earth is how much? That galaxy is in motion now, it's understood. Otherwise this type of a variation we would not have got. When we people are finding a difference in the wavelength means the source is supposed to be in motion. As long as the source is at rest, for example, is concerned, there will never be any change in the wavelength, we all know that. So what is the concept here now? Since the galaxy is in motion, there is a change in wavelength. So first understand that. And estimated speed of the galaxy with respect to the earth is how much? Four options are mentioned once again. 3.2 into 10 power 8 meter per second is the first option. And second option is 2.2 into 10 power 7 meter per second. And third option 4.2 into 10 power 6 meter per second. And fourth option given is 1.2 into 10 power 5 meter per second. Okay, if you just want to estimate the answer like without doing anything, at the most you can leave the first option. Reason of course is better known to you all. Velocity of light is 3 into 10 power 8 meter per second. Of course, nowadays we are having some different concepts, but theoretically speaking, there is no such object or body which can travel with greater than the velocity of light. Velocity of light is the ultimate value according to physics in general. Therefore, first option being 3.2 into 10 power 8, you need not consider that, okay. But Unfortunately, such type of values, if they give 3, we can leave them and take the 4th. That is a different issue. But here he has given only 1. So we have to identify from 2nd, 3rd and 4th options what is the correct value. What is it we people have to take now? If I just take this one as lambda dash by lambda, that now can be taken c plus v by c minus v whole under root. This lambda dash being greater and lambda value being smaller, c plus v by c minus v. So what we can directly write in this particular case, please? This value of lambda dash now is going to be, that is c plus v by c minus v is going to be 706 by 656 whole square. Now, just by taking this value and simplifying the value of v, you will be getting from this directly v is equal to around 2.2 into 10 to the power 7 meter per second you will be getting. And observe what is the c value here. C is 3 into 10 to the power 8 meter per second as such. This is velocity of light which is known to every one of us. Only thing is, you just have to simplify this one 706 over 656 whole square. That roughly estimate and cross multiply that and take the value of c over here and simplify, you will be getting v as 2.2 into 10 to the power 7 meter per second. So that particular galaxy what he is talking about in this problem is having certainly greater velocity. It's 2.2 to 10 power 7 meter per second. With that velocity, that particular galaxy is approaching. That is actually the concept. You people just have to understand. It's moving over there with that much of velocity. So the correct option is tallied with the second option given there. Therefore, the correct answer for this particular question is B. Only point is calculation is a little lengthy, not difficult. Remember that. It's a little lengthy. So definitely you can work out that, and it's 2.2 into 10 power 7 meter per second, which is the velocity of that galaxy. That is estimated speed of that galaxy is that much. That is problem number 44 what we people are having here.